Okay, this is just a quick review because I know that you've been doing this. We did this in a previous mod, and also you've been doing this in your homework. But if you could take a second to do this, to answer these questions, true or false, and then we'll look at it together. Okay, 6 plus 2. 6 plus 2 is 8. 2 plus 6 is 8. So that's true, right? Here, 6 divided by 2 is 3, but 2 divided by 6, that's not 3. 2 divided by 6 is 1/3. So this is false. This is 0.333, less than 1. 0.333 with a line over it. Okay, and this is 3. Okay, 6 minus 2 is 4. 2 minus 6 is -4. So this is also false. 6 times 2, 12. 2 times 6, 12. This is true. And yes, what are we discussing again? We are discussing a commutative property. Commutative, remember, means that you can go back and forth. You can commute. And the commutative property holds means it's true for addition. We're allowed to change the order. And multiplication. We're allowed to change the order. Cannot change the order in division. Cannot change the order in subtraction. So the commutative property only works for addition and multiplication. And you'll see that rule on your slide. Okay, let's take a look at these together. Okay, order of operations tells us parentheses first. So 3 plus 5 is 8. 6 plus 8 is 14. That's the left side. We want to know if this is true or false. Let's look at the right side. Order of operations, 9. 9 plus 5 is 14. So yes, this is true. Think about what we're probably going into that you've already done. Okay, so we have here, a little harder, 6 divided by 3 divided by 5. Well, I could just do this, 3 divided by 5, okay? And now I want 6 divided by that. Well, 6 divided by that is 6 times, 6 times 5/3. 3 goes into 6 twice, and we get 10. So this side is 10. What's this side? 6 divided by 3 is 2. And 2 divided by 5 is 2/5. So these are not the same. So this is false. Okay? Multiplication, same thing. Order of operations, 6 times 15. And 6 times 15 is 90. And this is 18. 18 times 5. And 18 times 5 is 90. So this is true. Okay? So we got this one is true. This one is true, but this one is false. What about subtraction? You know where we're headed, right? Subtraction. Let's take a look at this. I have 3. I owe you 5, so I owe you 2. This is 6 plus 2, which is 8. Let's see what this is. 6 minus 3 is 2. 2 minus 5 is -3. So this side, the right side, is -3. So this is, again, false. So what did we do in this problem? All we did was we did not change the order because 635, 635, same order. So it's not commutative property. But who you played with changed. Here the 3 was playing with the 5. Here the 3 was playing with the 6. If you remember, that's called the associative property where grouping changes. And just like commutative property, you can only change the grouping in addition and multiplication. And you'll see that in your workbook in your next 2 slides. It talks about the associative property of addition and of multiplication. Okay? Now, you're probably thinking, why do we care? Well, let's see why we care. In your workbook, it has this. Quickly find the sum. And I'm sure you can do it quickly, but I want to make a point here. So here's my point. Even though there's let's try that again. Even though there's no parentheses, people like to go from left to right. But if you think about this, I can associate the 3 with the 97. I can group them up differently. And that would make my life a whole ton easier because 97 plus 3 is 100. And then 100 plus 89 is 189. So we actually use the associative and commutative property all the time, even when we don't know we're using it. And that's what I like. I don't like to name exactly when I use them, but I know that I do use them. I use them even when I do things like this. 6x plus 3x. Okay? Sometimes I have x's in my problems and I want to regroup them or change the order. I do it all the time. So we know we use them, we just don't always have to tell you when we use them. But that's the glory of them. We can change things around, we can group them differently, and all those other things we want to do. There's 2 ways to do this. One way is I could actually plug in numbers, stay away from 1 and 0. I could actually plug in numbers here and see if this is true or false. However, a better way is to really understand and apply the property. So see what's going on. Here's what's going on. I have this factor x plus y and this factor z. And all I did was change the order. So I changed the order of what I am multiplying. I am allowed to do that. Okay? And that's called the commutative property of multiplication because I changed the order of what I was multiplying. Even though there's addition here, I'm not changing the order of anything inside those that parentheses. So this is true, and only when it's true can we have a property, and the property is commutative property of multiplication. Okay, so that's the property. All right? So I'm going to ask you to do 2, 3, and 4, label it true or false, and if it's true, name the property. Remember, there can only be a property because a property means it's true, and it tells you why it's true. There can only be a property if it is true. Okay, let's see how you did. Let's look at this one. Let's look at the y and the z and the x and the y. Notice that this is in the order x, y, z, and this is in the order x, y, z. So we did not at all change the order. So it's not commutative property. Is it associative? Well, here the x is playing with the y, and here the y is playing with the z. So it is the grouping changed, so that is the associative property. So this is also true, and it's associative property of multiplication. Okay? Let's look at the guy down here. We could obviously do this problem, but I don't want to. I want to make sure I understand the properties. So let's see what happened. Okay? This is a factor. This is 2. 6 divided by 2 times 3. And that didn't change. The multiplication part didn't change. I'm still multiplying this times this. It did not change the order. Okay, but what did change the order is what's inside the parentheses. So here the 6 was first, then the 2. Here the 2 was first, and then the 6. So my order of what I'm dividing changed. Can't do that. Can't change the order of what you're dividing. Just of what you multiply or what you add. So this would be false. Okay? Let's take a look at this one. This one, the 3 came first, and then the 6 divided by 2. Here the 6 divided by 2 came first, and then the 3. So we switched the order. We didn't change the order of what we were dividing. We just switched the order of what we were multiplying. We are allowed to do that. So again, this is the commutative prop. This is true, and it's the commutative property of multiplication. And that's it. I know these were all multiplication when they were true, but it's okay. We have more examples for you. I'm going to try the next one with you, and then I'm going to ask you to do some on your own. All right, I guess I think addition is pretty boring because only this one is addition here, but okay, let's do it. I'm going to show you how to do this one. I want to state an equivalent expression with a given property. So I want to show commutative of multiplication. That means to me, change the order of what's being multiplied. So this is what's being multiplied, the 5 and the parentheses. So I'm going to have to change the order of what's being multiplied, not of what's being added. So I do not change what's being added. So I keep that exact same order and just move the 5. I'm done. That's a equivalent expression using commutative property of multiplication because I changed the order of what's being multiplied. So if you would do the next 3, and then we will check them. All right, commutative of addition. That means I have to change the order of what I'm adding. So the only thing I'm adding is the 3 and the 7. That means they have to change. So it's 7 plus 3. That's it. Can't change the order of anything else. Otherwise, I would also have commutative of something else. Okay, so that's it. I'm done there. Associative of multiplication. Okay, associative means if it just says associative, and sometimes there's 2 in 1, associative and commutative, where you change the grouping and change the order. But that just says associative. That means I can't change the order. That means 6AB has to stay in that order. However, I have to change the grouping. So instead of 6 with the A, it's A with the B. And now I've changed the grouping. And that's it. That's the end of that problem. Now this problem, commutative of multiplication. Commutative of multiplication. Now, actually, there's 2 answers here. Because we have to change the order of what we're multiplying. So either we could do this, and it will change this with this. Or we could do, no, we could do this also. We could do this. We could, you had, remember, 6A B, that's what you had. What if you change the order just inside here? A6B. But I have to tell you that that looks funny. I like this answer better. This is an okay answer because you did what you're supposed to, but A6 looks so funny. Generally, when you write an expression with a coefficient, the coefficient goes in the front. But I can't mark that wrong because you did what you were supposed to. It's just awkward. Okay? All right, so that takes care of that slide. Now, there's one other thing that I want to talk about that we haven't talked about before, and I'll do that when I come back. Okay, there are some other properties that we never talked about in previous mods. One is the identity element. The identity element is almost what you'd think of. For instance, when you look in a mirror, okay, what you see is what you have. Anyway, we won't look at that again. But the truth of the matter is, the identity element tells me that the identity element of addition and multiplication, there are two. The identity element of addition says that if I add something to a given number, I want to get that given number back. Okay? So that's what so that given number remains unchanged. Okay? The one for multiplication says if I have a given number, I want to multiply it by something to get that given number back. So what do you think the identity element for addition is? What would fill in the blank here? Let's think about that for a second. Well, it's obviously 0. 0 is the identity element for addition. Okay? And for multiplication, 6 times what would give me 6? 1. 1 is the identity element for multiplication. Okay? Same thing here. 75 plus 0 will get me back. 75 times 1 will give me 75. So 0 is the identity element for addition, and 1 is the identity element for multiplication. Okay, so again, 0 is the identity element for addition, because I added to a number to give me back that same number. In symbols, if you look in your workbook or on your slide, this is what it says. It says A plus 0 equals A, making A 0 the identity element for addition. And it says A times 1 equals 1A or A, making 1 the identity element for multiplication. So that's what it says in your workbook and on that slide in symbols. That's how you designate it. Okay, the inverse property is the last property I want to talk about. The inverse property actually gets you back to the identity element. So the inverse property for addition, okay, the additive inverse is what you would call it. The additive inverse means I'm going to add something to this number to get back to the identity element for addition. Right? This is the identity element for addition. Okay? Same thing here. This is the identity element for addition. Okay? So the inverse property means I'm going to add something to that number to get back to 0, because inverse gets us back to the identity. Okay? So what can I add to 7 to get back to 0? Well, that would be -7. What could I add to -1/2 to get back to 0, the identity element? That would be 1/2. Okay? There is actually another name. This goes, you know, we're calling it the additive inverse, but there's another name for the additive inverse. Okay? This is called the additive inverse, the additive inverses of each other, but there's actually another name for it. What is another name for additive inverse? It is opposite. Right? We know that word. Same thing. Same thing. Okay? In multiplication, we have the, oh, I love this. Listen to this word. Multiplicative inverse. I love that word. Multiplicative. We have the multiplicative inverse. I even like the way you spell it, because it spells just like it sounds. Okay. The multiplicative inverse means to multiply a number by some number to get back to 1. To multiply a number by some number to get back to 1. Well, if you think of this as 7 over 1, what could we multiply 7 over 1 by to get back to 1? Well, that would be 1/7. What could you multiply -1/2 by to get back to 1? That would be negative, because it's got to be the same sign to get a positive back, 2 over 1, or just plain -2. Okay, so what is another name that we have for multiplicative inverse? And that would be opposite. So, not opposite, I'm sorry. I said opposite. Sorry, reciprocal. Multiplicative inverse is the same as the reciprocal. So reciprocals are the same thing as multiplicative inverse, and the opposites are the same thing as the additive inverse. And additive inverse brings you back to the identity element. Okay? Let's see why we care. All right. Okay, let's see why we care about this. Why are we making a big deal about inverses and all this stuff? Inverses, all these properties. Well, we already said we can move around the way we multiply or add things. Well, look, or group them differently. Same thing here. There's two things now. I can group them this way, 3/4 times 4/3, and I'm going to tell you why I really want to. Not only do I want to group them differently, but I care about grouping it this way because these are reciprocals. And when I multiply reciprocals, I get back 1, which is the identity element for multiplication. So this is just 1 times 2.531, which is 2.531. So I made it really simple to multiply these. A lot of times we use all of these properties, and we don't even know we use them. Same thing here. I want to add this with this. Why do I want to, oh, there was a parenthesis around this also. I want to add this with this. Why do I want to do that? Because they are opposites. And when you add opposites, you get back to 0, the identity element for addition. So now that's 0 plus 4.3, which is just 4.3, makes it really, really, really easy to add. So it's just a good idea to understand some of these properties and know why they're useful. And that takes care of that lesson. We're moving on to lesson 2.